of you. Today I want to discuss about the testing of hypothesis. Okay. So first of all, what is the hypothesis? So first I will explain the definition of hypothesis. So hypothesis. So generally hypothesis is a definite statement about the population parameters. Definite statement. Different definite statements are available in our society. So I will tell some examples about the hypothesis. In the city, for suppose all are the smokers is the one example of the definite statement. The teaching methods in a particular school are very effective. That is also definite statement about the hypothesis. So for the average men, the mean of the shoe size of men 7 inches. That is also definite statement about the hypothesis. So all these are the definite statements. So that is called the hypothesis. A definite statement about the population parameter is called the hypothesis. Generally, hypotheses are classified into the two categories. One is simple hypothesis. Simple hypothesis. Another one is composite hypothesis. Composite hypothesis. So first we will discuss about the simple hypothesis. So simple hypothesis means any statistical hypothesis, the information is complete, specifies the information completely. That is called simple hypothesis. Otherwise it is called the composite hypothesis. So the information specifies completely means, for example, let x1, x2, xn draw a samples drawn from a normal population with mean mu and variance sigma square. So what is the complete information about the normal distribution? The random samples are drawn from normal population with respect to mean is mu and variance is the sigma square. That is the complete information. In that complete information we want to test the hypothesis, simple hypothesis. For suppose I am say that that hypothesis H mu is equals to mu naught, comma sigma equal to sigma naught square. So this is the example of the simple hypothesis. H is the hypothesis. H is denoted by the hypothesis. Mu and sigma square are the parameters. Mu and sigma square are the parameters. So so mu consider the value mu naught. Sigma square consider the value sigma naught square. Generally, I told clearly the definition of hypothesis is the definite statement about the population parameters. Population parameters, you are telling the statement about the single parameter, or you are telling the statement about the double parameters or multiple parameters. So here the normal distribution was considered. In this normal distribution, two parameters was applied. One is the mu, another one is the sigma square. So mu and sigma square are the parameters. This is the definite statement. Mu equal to mu naught, sigma square equal to sigma square. These are the two definite statements. Two definite statement, that is called the simple hypothesis. Otherwise the composite hypothesis. What are the otherwise? So many otherwise cases are available. What are the otherwise cases are available? For suppose H mu not equal to mu naught, sigma square equal to sigma naught square, H mu equal to mu naught, sigma square not equal to sigma naught square, mu greater than mu naught, sigma square equal to sigma naught square, mu less than mu naught, sigma square equal to sigma naught square. So etc. All these are the alternatives, alternative statements of the simple hypothesis. So this is the composite hypothesis. Okay. So next we will discuss about the testing of hypothesis. So this is the hypothesis. Hypotheses are classified simple hypothesis, composite hypothesis. Next we need to test that hypothesis. Simply oral I speak the definite statement about the population parameter. How far it is true, whether it is the all the statements are correct or not. So we need to test that hypothesis. So what is the requirement to need the test of hypothesis? Generally the testing of hypothesis depends on the two action decision problem. So one is acceptance, other one is the rejection. Depends on the acceptance and rejection, we will tell the conclusion about that statement. Okay, we will tell the conclusion about that statement. So that is the testing of hypothesis. Okay, so next, after discussion of the testing of hypothesis, generally we will come across, there are another two types of hypothesis we will come across: null hypothesis and alternate hypothesis. So null hypothesis is nothing but simple hypothesis. Alternate hypothesis is nothing but composite hypothesis. Composite hypothesis. So I will tell the example before I will discuss the definition of the null hypothesis. I will explain one example. I think you are understanding clearly. So what is that? I will tell one example of the null hypothesis. What is an example? Let us consider the average marks of the students in the particular class. We will consider we want to calculate the average marks of the students in the particular class. So how to calculate? Different parameters are there to calculate the average marks to the marks of the students in the class. Okay, students in the class. So after this is the one process they are adopted. They are calculated the average marks of the students in the class. Later, sometimes using some advanced techniques, they are also again they are calculated the average marks of the students in the particular class. Okay, so that means the class or college, they are calculated the average marks of the students. They are applied the two types of techniques. One is the old technique, another one is the new technique. Old technique also they are calculated the average marks of the student. New technique also they are calculated the average marks of the students. So in these cases, in this concept, there are three cases will be erased to give the conclusion. Okay. So what are the three cases are erased? One is first technique. First technique greater than second technique. Second technique. Second technique. Second technique less than second technique greater than first technique. First technique. And there is no difference between these techniques. First technique equal to second technique. So like this, these three cases will be arranged to the decision makers or business makers. So this is first two cases. This is case 1, this is case 2, and this is case 3. So the first two cases are the biased results. Biased results. So first technique is greater than second technique. Second technique is greater than first technique. So if you are adopted these two techniques, so the results will be come into that biased. So biased. So automatically the third one is the gives the results of the unbiased. That means first technique is equal to the second technique. There is no difference of the both techniques. So what are their aim to decision makers? What is this example? Main example. They are calculating the average marks of the particular class of the school or college. So they are applied the two types of techniques. One is the first technique. Second one is the new technique or second technique. So there is no difference between these two techniques. So this is from this statement. Statement they are give the results are gives in terms of the unbiased. So the decision makers or statisticians, they are adopted this technique mainly. So that means what is the meaning of this one? There is no difference between the process. There is no difference. So what is that is called the null hypothesis. That definition is called the null hypothesis. So null hypothesis is nothing but no different statement about the population parameters. Null hypothesis is nothing but no different statement about the population parameters. So this is the no difference. No difference. That's why null hypothesis is nothing but simple hypothesis. So mu equal to mu naught, there is no difference. Sigma square equal to sigma square, there is no difference. This is also one example of the null hypothesis. So null hypothesis is nothing but null hypothesis is denoted by H naught. So we will consider any example mu equal to mu naught. This is one example of the null hypothesis. If you consider one parameter, this is the mu equal to mu naught. For suppose if you consider the two parameters, how we can consider the two parameters? I will tell another example. For suppose there are two schools are there. They are calculating the average marks of the students of the schools, average marks for school 1 and school 2. The average marks of school 1 is mu1 hours, mu1, and the average marks of school 2 is the mu2. So what is the null hypothesis in this case? H naught mu1 equal to mu2. So mu1 equal to mu2 means I told clearly the definition of the null hypothesis. There is no difference between the statement. There is no difference between the population parameters. No difference means mu1 equal to mu2. Average marks of the school 1 mu1 and average marks of the school 2 is mu2. There is no difference means mu1 equal to mu2. So null hypothesis is denoted by H naught. So whatever the alternatives are applicable for these two statements, H naught mu equal to mu naught and H naught mu1 equal to mu2. So the alternatives are nothing but the alternative hypothesis. So alternative hypothesis is nothing but composite hypothesis. All these statements are belongs to the alternative hypothesis. All these statements are belongs to the alternative hypothesis. Okay, null hypothesis is nothing but simple hypothesis. Alternative hypothesis is nothing but composite hypothesis. So alternative hypothesis is the rival hypothesis of the null hypothesis. So that's why for any testing of hypothesis problem, alternate hypothesis play very important role. Why? Because in this there are different types of alternatives. So some alternatives may be not equal, some alternatives may be greater than, some alternatives may be less than. So we want to choose the particular concept is belongs to not equal to greater than or less than. So that is very important. So that's why alternate hypothesis play a very vital role in our testing of hypothesis. Okay. So next we will discuss about that errors of the sampling. There are errors of the sampling. Generally, in our sampling theory, there are two types of errors. Why the errors are occurred means maybe we need to valid a statement to valid inference or statement to the society. Automatically, the some portion of the errors will be occurred into our calculations. So there are two types of errors are occurred in sampling theory. What are the two types of errors? Type 1 error, type 2 error. Type 1 error, type 2 error. So type 1 error. So the type 1 error. What is the type 1 error? I will tell clearly. The error of rejection of H naught when H naught is true. The error of rejection of H naught when H naught is true. See, that is called type 1 error. And what is the type 2 error? Opposite. We are thinking the opposite. So the error of accepting H naught when H naught is false. H naught is false. Type 1 is the error of rejection of H naught when H naught is true. Type 2 error oppositely. The error of accepting of H naught when H naught is false. What is this? So just I will tell one example. Clearly, maybe we are understanding clearly. Type 1 error, type 2 error. So for type 1 error is nothing but producer risk. Type 2 error is nothing but consumer risk. Producer risk to consumer risk. Why the type 1 error is called the producer risk? Why the type 2 error is called the consumer risk? I will tell one example clearly. For suppose I want to go for buy a television for the television shop. Okay. So in the television, the design, the shape of the design, the features are not good. The shape of the design is good. Shape of the design is good, features are not good. Shape of the design is very good, features are not good. So the shape of the design is not good, all features are good. So shape of the design is not good, features are good means nobody will interested to buy the television. Maybe somebody will buy, but nobody interested to buy the television. Automatically, who will bear that cost? Producer will bear the cost. From this, what we are understanding, the statement is true. What is the statement? The features of the television is very good. All features of the television is very good. Only the shape of the design is not good. Shape of the design is not good. Somebody may be rejected. Not all members will be rejected. Somebody is only rejected. Not all means 100% may be not rejected. Maybe 5% or 10% or 2% or 1% will be rejected. Here the errors may not give the more. Errors are very less. Maybe 5%, 1% to 2%, 10% maximum may be occurred, not more 100%. So that means that is the producer risk. So think oppositely for that example. The shape of the design is very good. All features are not good. All features are not good. Shape of the design is very good. Somebody will buy the television. After sometimes the television will be damaged. So who will be the responsible? Who will be the responsible? The consumer will be the responsible. So from this what we are understand? The shape of the design is what we are understand. The statement is false. What is the false statement? What is the false statement means the shapes are the features are not good. That is the false statement. But somebody will be accept. So that is the type 2 error. So type 1 error, type 2 errors are the consumer risk, producer risk and consumer risk. So thank you. Next video we will discuss some other things of the testing of hypothesis. Thank you.